Hi, welcome to lab activity 4. It's about on node voltages. We have learned the node method in the theoretical course, and we will make some lab activity and simulation activity on node voltages. Lab 4A part says make the simulation of the circuit on Multisim and email it to your teaching assistant. You will draw a circuit like this, and as you can see, the node voltages are here, and you will email it to your teaching assistant. And in the B part, you will construct the circuit, and as you remember, it's the same circuit with KVL KCL circuit. So in KCL KVL circuit, we have measured the branch voltages and branch currents, and in this activity we will measure the node voltages. Yes, let's look at the real circuit, actual circuit. This is our circuit. This is 9-volt battery. This is the switch. These are the resistors. And the negative side of the battery is connected here. I will assume this node is ground, so it's accepted as 0 volts, and I will measure the node voltages of other points with respect to these points. This is my multimeter. To measure voltages, I should adjust the knob to voltage measuring, and the connections are like this. Black is connected to COM port, and the red is connected to the voltage port. And now I can measure the voltages. This is black probe. I should touch it to the negative side, negative terminal, and I should touch the red terminal to other points. For example, this is E1. I cannot read any voltage because my switch is off. I should make it on. Now it's on. Now I can read the voltage of that point. The node voltage of that point is approximately 9 volt. It's actually equal to the voltage source. Yes, 9.33 volts. It's the voltage of voltage source, positive side. And let's read the voltage of node 1, unknown node. As you see, it's 4.30, and the other voltage, unknown node voltage, I can read a voltage of 5.5 volts, 5.05, excuse me. So these are the node voltages if I accept this point as a ground. For example, if you assume this midpoint as a ground, then you have to touch the negative side of multimeter to this point and then read the node voltages. Okay, now I am assuming this point is ground, and now the node voltage of upper side is 5.04, and the node voltage of this point is 0.743, and the node voltage's bottom point is minus 4.31. Okay, actually there is no change in my circuit, but if I change the ground convention, ground assumption, the values will change. And the important point is the branch voltages, and as you change the ground, branch voltages will not change. Okay, branch voltages are always same. Look, the branch voltage on this register is 0.7, and the branch voltage on this register is 5 volts, and the branch voltage on this register is 4.31 volts. Okay, they will not change when you change the ground. And if you wanna read the current of a resistor, for example, I will measure the current of this resistor, and it's flowing from E1 to E2. Okay, it's flowing in this direction from left to right. I have to open the branch. Okay, now I have opened the branch. There is an open circuit here, and I have to change the adjustment of my multimeter to milliamp measurements. Now it's in the adjustment of milliamp measurements, and I have to change the probe to milliamp measurements. Now I can measure, and I have to insert my ammeter or multimeter in series to measure the currents. Look, if I am measuring the current from left to right, I have to touch the left, I have to touch the red probe to the left and right probe to the right, black probe to the right, and I can read the current now. It's minus 0.5 approximately milliamps. Okay, and if I change the directions like this, I will measure the current flowing from right to left. It's the opposite polarity of previous currents, positive approximately 0.5. Okay, I will read the same value, but the polarity changes if I change the polarity of probes.